An estimated 311 billion kilowatt hours were used in 2007 to light commercial spaces in the United States. California ranks second in the nation in total electricity and energy consumption. Much of this use can be attributed to commercial office buildings, where overhead lights are left on for hours, regardless of occupancy or daylight. We aim to change that. Adura Technologies, in partnership with the CLTC, a research and design facility at UC Davis, and the California Energy Commission's Public Interest Energy Research Program, developed a wireless lighting control system that allows facilities to cut energy use without costly and complicated rewiring. In many buildings, all the lights on a floor or in a section are operated by a single light switch. This is inefficient. Occupants have no control over the amount of light entering their spaces, and often the lights are on all day and night, wasting energy. A new demonstration is in progress at the University Communications Office. Adura occupancy and personal controls will be installed on half of MRAC's third floor. The Adura system introduces scheduling, daylighting, occupancy sensing, and personal controls in individual workspaces without rewiring. Here's how it works. At the core of the Adura system is the light controller, which communicates wirelessly with additional system control components using low-power radio waves that adhere to the Zigbee standard. System components communicate through a mesh network, reducing the need for additional control system wiring. The mesh networking is strong enough to operate in most environments, including parking garages and other challenging spaces. The radio waves communicate with the Internet via a wireless gateway. Facilities managers can remotely supervise their building's energy use, predict lamp or ballast failures, and otherwise control the system. The Adura system efficiently modifies the lighting environment to achieve light levels designated during the commissioning process. A recent study indicated that corridors and hallways account for 30% of the energy used for lighting the campus. Wireless controls can reduce this number drastically. A demonstration at the California Lighting Technology Center experienced about 63% energy savings in an interior hallway, where occupancy and vacancy components of the Adura system were tested. The lights are dimmed to a lower level or turned off until a person enters the space, activating the system.
The Adura system is easy to install. Instead of costly rewiring, the light controller is attached to the ballast in an overhead fixture. This allows for the fixture to wirelessly communicate with other components in the system, such as the ones found here. The components can be located anywhere, such as the sensor interface, the wall control, and the gateway. The gateway can be used for users to control their lights through the online interface.
The system can reduce energy consumption by 40 to 70%, depending on system components and building configuration. It also allows companies to participate in demand response programs sponsored by local utilities to save additional money. The system can be set up to respond to daylight, so that the lights dim when adequate daylight is available. Additionally, users can have personal control of the ambient light over their workspaces.
Here at UC Davis, we take saving energy seriously. If I'm not in the office, the lights shouldn't be on. It's a simple but effective way to save energy. And with automated lighting controls, it's more likely we'll see the energy savings we're after.
The Adura system can be installed in a single office or hallway, parking structures, or an entire building. It's compatible with electronic or magnetic ballasts for fluorescent applications, and incandescent lamps and HID ballasts. The daylighting feature was demonstrated on 10 fixtures in a parking garage at the University of California at Santa Barbara, saving over 12% annually. The Adura system will wirelessly transform your structure into an energy-efficient building where employees have more control over their workspaces and facility managers have more control over energy use.